Completing the initial build of an enterprise performance management system simply marks the transition from development to a permanent operational cycle. The moment a new SAP Analytics Cloud deployment is launched, it begins to accrue technical debt if left unmanaged. This happens because SAP Analytics Cloud is a dynamic platform. SAP delivers continuous updates to the environment, deploying patches on a bi-weekly basis and pushing major release waves every quarter. These updates introduce significant architectural shifts, such as the move towards seamless planning with SAP DataSphere. Because these changes are pushed automatically, the underlying environment is in a state of constant evolution. If a planning model remains static while the software environment around it shifts, the custom logic and architecture will eventually misalign with the platform's optimal execution paths. Traditional on-premise deployments allowed for a flat maintenance schedule, but a continuous delivery cloud platform requires a different approach. To protect the initial investment, organizations must shift from a finite project mindset to a continuous governance and maintenance pipeline. Without an operational framework to ingest these updates, even a perfectly engineered planning model will see its performance and utility decay within a few months. Building this pipeline requires a disciplined environment strategy. Even within a unified cloud ecosystem, strict physical workspace separation is mandatory to absorb updates without risk. This strategy relies on three pillars: dev, test, and prod. In dev, developers test capabilities and evaluate enhancements. Stable updates move to test, where users validate changes against real-world scenarios. Finally, prod houses lifecycles, using strict access controls to protect master data integrity. Within this production environment, it is also necessary to enforce a clean model policy for the public directory. During active forecasting, planners often create ad hoc private versions and duplicate stories. If left unmanaged, this accumulation of data adds significant overhead to the backend. Strict naming conventions and organized folder structures ensure temporary files are identified and cleared regularly. This workspace segregation allows for the testing of new updates while guaranteeing that live business operations remain uninterrupted. With the environment structure in place, the organization can safely evaluate SAP's constant enhancements, such as new predictive forecasting tools. Managing this requires an SAC innovation steward. This technical lead or power user acts as the gatekeeper for new features. The steward reviews the release notes before quarterly updates hit the system, filtering for features that impact current operations. This leads to the impact analysis phase, which must be completed before any release reaches the production environment. The analysis focuses on three areas: existing data actions, allocations, and data locking rules. During the preview wave, the steward runs scheduled regressive smoke tests. These tests confirm that formulas recompile smoothly and that high-volume planning stories maintain their performance benchmarks. Without this step, a platform update could unintentionally break allocation logic or degrade the system's responsiveness during a live planning cycle. Proactive pipeline management ensures that the system remains stable and performant as it incorporates the latest functional improvements. Planning models are living systems. As the data volume increases over time, the system's performance can drift. To mitigate this, technical leads must optimize the planning areas. By using data access controls, you can restrict the editable data scopes to a specific cluster of cells. This prevents the system from loading a multi-year dataset into memory when a user is only making a localized budget adjustment. Beyond data scope, the model structure itself requires maintenance, specifically through recompilation. Whenever dimensions or master data attributes are modified, the advanced formulas must be resaved. This action forces SAP Analytics Cloud to optimize the backend execution path for those formulas based on the new model structure. The final technical requirement is routine housekeeping. Scheduled cleanups are necessary to keep the system lean. These cleanups target stale private versions created by planners during previous forecast cycles. A system cleared of redundant data versions remains responsive, while a cluttered system will experience significant query lag. Regular scheduled optimization is the primary defense against platform stagnation. Maintaining the technical backend ensures stability, but the models must also stay aligned with an organization's shifting macroeconomic landscape. To ensure this alignment, organizations should establish a monthly Change Advisory Board, or CAB. This board brings together leadership from finance, operations, and IT. The CAB's function is to systematically evaluate new business needs and determine the best way to implement them. When a new requirement arises, the board decides whether to modify the existing model or to leverage a newly released native feature from SAP. Because the platform is constantly evolving, the organization must budget for continuous learning. For example, a requirement that once necessitated a complex workaround yesterday may now be a standard one-click feature today. Effective governance is built on 4 pillars. First, environment segregation. Next, innovation management. Then, technical maintenance. And finally, organizational alignment. Treating SAP planning as a continuous program ensures the platform remains agile and consistently utilizes the latest features and optimizations released by SAP.